So today we are going to discuss about industrial finite element analysis. First of all, thank you very much to HOD sir for inviting me for providing this lecture for you all. So I'll start my session. As I got HOD sir given a very good introduction about me, there is nothing much that I'm going to say on this. I'll directly jump onto the content. So here we are going to discuss about industrial finite element analysis. So here basic things like for few slides I assigned like I created the basic FEA. How we are doing the finite element analysis and what is the meshing and what are the points we are having, nodes we are having, like that each and every segment we are going to discuss now. And once the basic understanding on this area, because FEA is a very vast subject where we are having many content, more content into this. But here within this session, I'm not calling all the points. And even if I am having some of the slides which is having more in-depth means, I will skip, and whatever the required things which is easy to understand to you, we will discuss in this session, because I'm having more number of slides here, but still there are many slides which is very difficult for you to understand on this area. So those kind of things I will skip on upcoming things, and then very important slides we will discuss in detail. And there are more case studies we are going to discuss in this session. Any doubt or clarifications, once we complete this session you can ask. I will explain you whenever you are having some doubts or something means, you just make a note. We will discuss after this session in a doubt clarification sessions or a discussion session. Yeah. So first thing, finite element analysis, where finite element analysis is the analysis. I'm not going to read the complete paragraph and I'm going to not explain the things. Just I will give you the key points so we can able to understand the things. So FEA, that is finite element analysis. How the name it comes? So like finite element method, we will call it is a numerical technique, where you can see here in the bottom drawing itself. So this is a, can you able to see my mouse, right? Mouse arrow mark. Anyone, can you respond?
Yes, sir. Yes, sir.
Yeah, yeah. So here we are having this component. So when we cut half into the half, that means cross section of this component, you can able to see here in the left side of this. So we are going to do the analysis. So what is particularly analysis? For example, before starting the analysis, what is the required thing? Design. Design is the basic fundamental thing we is required. For example, if I want to do analysis for this component, in the sense, first thing I want to create a component. So then only I can able to do a analysis. Okay. So analysis, we are having a different methodology. Just we will see one by one. Finite element method consisting in the modeling of generic problem, which involves continuous means in order to obtain mathematical description of the behavior. It is just a mathematical description, that's it. Okay. You can see here, this is basic thing, that is analytical method, experimental method, numerical method. There are three methods to solve any engineering problem. Just for a comparison, you can see in analytical method it is a very classical approach. In experimental method it is a actual measurement. What is the difference? Classical approach, in the sense, I can put a component in, design a component in a Creo or SolidWorks or any other CAD software, and I will put into the FEA analysis tool and I will get the result within a minute. So that is classical approach, which is a current approach they are using right now in industries. Okay. So in this we are having, we will get 100% accurate result. Okay. So whatever the solution we expected, it will a closed form solution. There will not be any deviations in the solutions. We will get the exact solution with this method, analytical method. So it is applicable only, but it is applicable only for problems like cantilever, simply supported beams, etc. Okay. So through analytical methods, it also give approximate results in the solution is not closed form. So we will get 100% accurate result in this analytical method. When we come to experimental method, whenever whatever we are doing in the software, for example, right now I'm doing some analysis in my current company for a particular project. So whatever the software is giving the result, we should not blindly copy paste in our report. It will create a problem. As a human, as a engineer, we want to analyze the issues, like results are right or wrong. We want to do a manual calculation, which is the base thing for analysis. Okay. So once the software comes, for time saving purpose, we are putting these things and we are getting the results within the time. But still, we want to cross verify the result whenever we are going to apply this analysis for a big projects. For example, if you are doing a flight design, in the sense that time we, with respect to software solution, just we are not copying paste and we are not putting the solutions into the things, it will create a huge problem. So in that case, we are going to get the results experimental method, with respect to the time, what is the time required and what is the actual measurement it is taking, physical prototype whether it is available or not. For example, in a bulk products, if you are doing a bolt or nut, in the sense, first I will create a single bolt or a n number of, like n is equal to 10 number of bolts. So everything is matched with the application or not, I will do inspection, then only I will go for bulk product. Like a similar way, I am using here for physical prototype, it is available or not, everything I am validating for myself. So with respect to the physically available equipment, strain gauge, elasticity methods, vibration methodologies, fatigue test, for these things and all, we are already having a different kind of equipments in the inspection area. For example, in companies and all, we are having a laboratory testing department itself. From my experience, I will I will tell one thing, like power transmission belts. You may hear about power transmission belts, which is used in cars and industries and all. So those kind of belts and all, we are having a separate laboratory testing area where we will test all the belts one by one. Like for example, we if we created a 25,000 belt per shift, in the sense, we will take n is equal to 5 belts. So only 5 belt we will take as a sample. We will take as a sample and we will cut the belt and we will do all the test whatever it is required to do for a belt testing. Then only we approve this lot. Like that, experimental method is very much important. Whenever we are going for analytical method, this is very important. Okay. The first one, the next one is numerical method. Numerical method is a basic method, mathematical representation, approximate assumptions will be made, applicable even if a physical prototype is not available, because it is an initial design phase. Even if we have to imagine ourselves that we are having this product, so I am developing the product. For example, I am designing a spring, in the sense, so what is the spring tension, what is, whether it is a compressive or this kind of data, we will assume ourselves and we will do according to the applications. Okay. So these kind of things. So finite element method, we are having linear, non-linear, buckling, thermal, dynamic and fatigue analysis. Where boundary element method, we will see in detail in upcoming slides. Just I am orally I am giving all the points here, whatever it is there. And finite element method, in the sense, we are having computational fluid dynamics, where the fluid pressures and fluid flow and all, we will analyze through computational fluid dynamics. That is one of the concept we are having. And finite difference method, in the sense, thermal, as well as thermal, in the sense, overheated area, the machineries which is having the heat things, so those kind of areas and all, we will do the numerical methodology. So these are the three different methods we are using till date, because once analytic method comes, experimental method and numerical method we are eliminating, means we are not eliminating that, we are using that also. These three combinations is very important to solve any engineering problems. Either it is a software, or it is a experimental method, or it is a numerical method where we are going for a basics things. The next one is, so approach towards problem. Okay. there are two types of approaches are there. One is continuous approach, one is discrete approach. You can see the picture. One boy is sitting in a stool, where in mathematical approach we will tell that a table or stool is creating a load, is we are placing a load into that. So we are having real time things like continuous approach. Okay, this is a discrete approach. Continuous approach in the sense it is a real component. We are placing that and we are observing and we are doing the analysis study. In discrete approach, we are going for a mathematical modeling approach. Okay, so from mechanical engineering, basic mechanical engineering, because this is a very important topic. That's the reason I am putting this. Why is our FE analysis? What is the purpose of this load calculation, spring calculation, this and all? No, these are the basic things which we are going to relate with the FEA. That's the reason I already said whichever it is not required, I will skip automatically and I will go for the next slide. But this is very important. That's why I'm giving in a detailed manner. Okay, so so here you can able to see from mechanical engineering point of view, any component or system could be represented by three basic elements. One is mass, another one is spring, another one is damper. These are the three things we want to consider. All the numerical method including FE finite element follows discrete approach only. Okay, so whenever I am putting my model into the FE analysis, it will go for discrete approach. Okay, because as a third person, as a 3D view, I can able to visualize the real life continuous problem. But whenever I am going to do software analysis, in the sense automatically the software it will do the discrete mathematical approach only. For example, meshing nodes and elements. It is a discretization of a continuous system with infinite degree of freedom to finite degree of freedom. That and all we will see in a detailed manner. Okay, so we are having different types of analysis. Okay, here you can able to see static analysis, linear analysis, durable analysis, thermal analysis. CFD means computational fluid dynamic analysis. Coupled field analysis. NVH means noise vibration, that analysis. Okay, so these are the different types of analysis we are using in a CAE, that is computational aided engineering. Okay, in this whole it will applicable for analysis. Now we can see there is I will explain you a concept. Okay, so how we are going to for a approach on FEA. So there are two phases. One is phase one. Phase one in the sense first we want to tell our problem statement. Okay, as I told you already, if I am going to analyze a component by analyzing tool, first I want a component. I want to design a component. That what here saying. So first problem statement. So what is the problem? So I want to do a sketch by hand. Okay, I want to do a sketch by hand. Just this is an example. But imagine whatever the component in your mind you can imagine. Okay, so when problem statement is defined, we want to do a sketch in hand. So once the sketch in hand done, we want to do a CAD design, that is 3D model. This is a sketch by hand is a 2D model where we will go for this front view, top view, side view, this kind of views we will do and we will create a sketch by hand. So once everything is done, we will go with CAD tool. In CAD tool, we will start to design this component. So once everything is designed, then we will go for analysis, that is CAE. Okay. So once the CAD design is done, we will go for analysis. Then once analysis is passed, okay, everything is done. Whatever the load we are giving, everything it is now withstanding the load and it is not getting any break. These kind of things we will get a result in the analysis area. And finally, we will do a prototype validation. Prototype validation in the sense with respect to the CAD drawing, I will start to do the manufacturing of this component. Once manufacturing is done, I will do a physical test. By applying the load, I will do the physical test. So whatever we are doing in the applying the physical load, just we are applying the load in CAE, that is FEA itself, and we are getting the results, whatever the results we are getting. So this is the phase one. Right now, in today's scenario, we are using this methodology in industries. Phase two. Phase two is design optimization. We are doing the optimization on the design. Optimization in the sense how it is behaving when we are applying overload. For example, this stapler, we can consider this item as a stapler. So we are giving a force in our hand. Okay, by using the thumb impression, we are doing this stapling process. So how much force I am giving and how it is bending and what is the maximum force it can withstand without changing its shape. So all the things we will do in this design optimization, because just like that we will not do the design and we are going to produce the component. We will check what is the failure rate, break even point, we will tell, right? So what is the failure range, when the what is the break even point it is getting failed. Like that we will do analysis, and we will get the results for our reference, so that I can able to tell, so this much load capacity only this tabler will withstand, and this is the place we can give high pressure. So other than that part, if you are giving means this component will get breakdown. So like that we will do a multiple design optimization, and this is the and the next picture you can able to see optimum solution. Okay, so where the rapid prototyping validation is done by doing this manufacturing as well as testing manually. Okay, so the next one is fundamental concept. Many engineering phenomena can be expressed by governing equations and boundary conditions: elastic problems, thermal problems, fluid flow, electrostatics, etc. So governing equation in the sense you can able to see there are two governing equations. Just you can view in depth of this is little bit will confuse you. So I kept this only. Okay. Amoni, can you mute yourself?
10, 9, 10. ఓకే నువ్వే చెప్పు కూర్చుంటావా
Hello.
కూర్చుంటావా అదా కూర్చో పడుతుందేమో అని 19
HOD sir, can you able to mute them? Is it possible for you?
ఏం కావాలి
Yeah. Thanks. So example, here you can able to see the concept too. That is vertical machining center. This machine usually in college itself we can able to see vertical machining center in so it is in, will be in the laboratory. So how we are going to approach this with respect to FEA, that what the details given here. So with respect to elastic, thermal, fluid, electrostatic, we are giving all the properties, behaviors, force. So with the based on the behavior, in the sense what is the displacement, what is the temperature. For example, elastic condition, what is the displacement, how much elongation it is happening. So thermal in the sense it talks about temperature, how much maximum temperature it will reach. Fluid in the sense it will call as a velocity. Then electrostatic, that is electric potential. So these are the behaviors and properties as well as forces is combined, and we are getting this formula. Okay, the next one is the same one, just we are understanding with respect to multiple machines. For example, here we are doing the formula for only single machine. Here we are having a multiple machines. It is very difficult to make the algebraic equations for the entire domain. So divide the domain into number of small pieces. Okay, what they are trying to say is this vertical machine directly if you are putting into the FE analysis means, because of this weight, because of the components, number of components, it will take more time to analyze, and it will be very difficult for the software to understand whether it is what kind of component and what is the things. So what it is trying to do is it is splitting up the finite element analysis is the part which is splitting up the items into each component, small components like square box. You can able to see in the picture, second picture, there will be a square box will be there for each and every cases. So the field quantity is interpolated by a polynomial over an element. It will consider the thing as each and every element. Each square box is a element, okay, and you can able to see the red dotted points. This is called node, okay. Each and every node, the node point, 1 point, 2 point, like that, each node and each box is a element. So what it is trying to say is adjacent element share the degrees of freedom at connecting nodes, okay. Here the degrees of freedom is very much important, since we are creating a elements for a very big vertical machine, okay. So finite element in the sense small pieces of structure, okay. The structure is converted into pieces. That small pieces of structure is called finite element, okay. So based on that, here you can able to see the result. once the Once the elements is fixed, splitted, and it is converted into analysis, so the formula is applied. This formula and all we will not do any hand calculation. It is a software based things only, so don't worry on that. Just for understanding purpose I shown here, okay. So this is also the same. The next one is engineering design, okay. Finite element analysis, we are having three steps, okay. One is pre-processing, second one is analysis, and third one is post processing. One by one we will see. Pre-processing, pre-processing in the sense creating a geometric model, develop the finite element model. As you can see the left side, it is a solid model where I am going to create this model in 3D CAD software. The next one is finite element model. Finite element model in the sense the similar way like whatever we are seeing in the vertical machine, right? In the similar way I am splitting the item into small pieces, okay. Whenever the small pieces is joined, you can able to see here they are circled and it is shown, right? So here it is called element. This box itself it is called element, and the dotted point it is called node, okay. So element and node, this is the very basic things. Whenever we are doing FEA, this is the very basic things for any kind of components, okay. How do we perform FEM modeling? First we generate a solid model. I already told you, like CAD software we are doing this and doing the finite element model. So FEM steps. So in these steps what we are going to do is, first we saw about pre-processing. Next one is post-processing. In pre-processing, I already explained you already. So we will directly move to post-processing. It is a compute moment at section AA. To compute the moment, we have to a bit of extra work that is called post-processing. Okay. So in finite element methods, we are having different types of elements like 1D element, 2D element, 3D element. 1D element in the things like springs, truss, beam. You can imagine say application. Springs, truss, beams, pipes, etc. 2D in the sense membrane, normal plate, shell, these kind of things and all. It is 2D element. Next one is a 3D solid element, which is having all 3D fields like temperature, displacement, stress, flow, velocity, etc. The next one is typical 3D solid elements. In 3D solid elements itself, we are having different types. That is only just a shape, tetrahedra type, hexahedron type, penta type. So these are the different kind of types. Okay. So in this, whatever the joinings are there, no points, that is called nodes. Here we will call linear points as a 4 nodes, quadratic as a 10 nodes, linear as 8 nodes, quadratic 20 nodes, linear 6 nodes, once again quadratic 15 nodes. So each different shapes having different kind of nodes, okay. This and all we will implement in our FEA softwares, okay. Whenever the split up is happening, this that kind of things and all it will happen. So here you can able to see FE models, substructures. Here you can able to see the substructures, that is supreme elements. Substructuring is a process of analyzing a large structure as a collection of natural components. The FE models for these components are called substructures. Okay. Physical meaning, a finite element method of a portion of structure. As I told you already, mathematical meaning, physical meaning, everything it will be there for a component. Boundary matrices, it will consider as a load and stiffness matrix. So everything it will come into FEA models. The next one is static structural analysis. Whenever we are doing analysis, we will have different kind of analysis as we saw earlier. Here it is, this is a static structural analysis. The concept whatever we are seen before, like splitting up the component into different pieces, nodes, different shapes, all it will applicable for these kind of structural analysis. First one is, here there are detailed analysis, detailed things will be given. Just I will give you a oral things, I will not read all the things, just I will give you a oral understanding on this. Okay. A static analysis calculates the effect of steady load conditions on a structure while ignoring inertia and damping efforts such as those caused time varying loads. Okay. So static analysis determine the displacement, stresses, strains, and forces in the structures. Okay. So it is called like types of loads. We can able to tell externally applied loads or pressures, steady state inertial forces, imposed displacements, temperatures, fluences, etc. Okay. So here we will talk about linear and non-linear analysis. A linear analysis mainly required linear elastic material and small displacement area. Only very small displacement happened in the sense we will call that as a linear analysis. While non-linear analysis they will tell us a large displacement and electroplastic materials. Okay. So whenever small displacement happen, we will apply linear analysis. Large displacement or elastoplastic materials it is happening in the sense we will call as a non-linear analysis. Okay. The next one is stiffness matrix. What is the difference in the stiffness matrix? In fact, the stiffness matrix remains constant during a linear analysis, but this phenomenon does not apply to a non-linear analysis. Okay. So once again, linear is non-linear. We are comparing the things. So geometric non-linearities and material non-linearities and the contact. Here you can able to see an example. Just we are putting a fishing uh, bow into the net and we are getting the fish in this thing. So image A, image B, you can able to compare. If a structure experiences a large deformation, it's changing a geometry configuration cause non-linear behavior. Okay. That is fishing pole you can able to see. So just I am putting the fishing pole into the water. So once fish I catch the fish, it is the shape is behavior is changing, deformation is happening in the fishing pole. So where it is experiencing a non-linear behavior. Okay. Material non-linearity in the sense stress strain relationship. That is the next picture. Like next picture, you can see stress strain relationship where yield stress everything it will come right. The same thing we are called as non-linear things. And the contact in the sense include effect of contact is a type of changing status non-linearity where an abrupt change in stiffness may occur when bodies come into or out of the contact. Friction or frictionless or rough contacts. Okay, you can able to see this left side picture. That is a green color. The red you can able to see. I will show the mouse. This red color is high friction area. This blue color is low friction or frictionless area, where this is the contact area. That yellow color, this touching right. This is the contact area. Okay. So in that way, once again, the linear and non-linear, it will define with respect to Newton-Raphson method and etc. Just I will skip these things by considering the time. So once again, you can able to see here modeling bolts. There are four ways to model bolts. Okay, without bolts, class 1, having bolt model as a beam, class 2, Having a bolt model as 3D geometry without a thread, that is class 3. Having a bolt model as 3D geometry with thread, that is class 4. So these are the different ways of modeling the bolt. Okay, this is actually a global standard also we can able to tell. In characteristic wise, bolt and interface are not taken into the consideration, so preload is not included in the representation. Okay, here in representation preload is not shown, but still preload is applicable for this, but it is not taken into the consideration. In class 2, once again, bolt is represented by a beam. Okay, preload and interface contact can be included. Here the red color is showing this contact is there. So internal force is acting in this area, that what they are trying to say here. Class 3, in the sense, bolt is represented by a volume body. Preload interface contact can be included, that is internal force is acting in the bolt. And fourth one is bolt is fully modeled and include threads, preload and contact all surfaces. Okay, so this is the standard they are explaining here once again with respect to the compliances and load applications. Okay, this is you can able to check in the VDA standard with 2230. This is one of the standard we are having for bolt joint list. Okay, and here once again modeling bolt, we are discussing here with respect to the standard, that is VD 12230 2003 standard. If you are taking in the sense, you can able to see here the calculation of bolt joint between a piston and a piston rod. Okay, in a hydraulic cylinder, as example of concrete concentric clamping and concentric loading. Okay, so these formulas, these calculations and all in FEA automatically it will calculate in within the FEA software itself. Okay, just we will give the input to the things just for understanding purpose. I shown this, and earlier I shown this bolt. Okay, modeling bolt. Here two ways of extracting bolt. One is using unbolt tool, which gives a working load, and another one is by planking or shank we can able to do the head cut operations. So with respect to that, this is one of the tool they are using for analyzing the things. This is also the same example for beam condition they are giving. Here this imprinted phase at the concentric equations we are giving applying for the based on the applications we are applying. Okay. So the next one is geometry or model bolts, how it is calculating. So one is beam element, another one is remote point or imprinted area with respect to the beam element, and another one is MPC equations with respect to 6 degrees of freedom. We are having a component having 6 degrees of freedom. So for all the 6 degrees of freedom, what is the node and what is the element we are defining with respect to the degrees of freedoms. Okay. So based on that, we are having this these calculations and all. It will take by FEA software itself. Just for understanding purpose, I given for our, in upcoming slides, I will show some applications where you can able to get more details on this. These details are given by the software itself. Here once again the mold of drawings we are giving with respect to that. Static structural analysis is going to end now, like a description of contacts. So I already told about contact, what is the contact surfaces and how it is implement. The same thing they are doing when two separate surfaces touch each other such that they become mutually tangent, they are said to be in contact. Okay, you can see here, this is one of the example. Contacts, the type of contacts that can be found in ANSYS workbench. Okay, in ANSYS FES tool you can able to see this kind of contacts. One is normal, but that is bonded, we will tell. In bonded, normal direction, tangential direction. In friction, normal direction, tangential direction. So just you can able to imagine that contact is happening with respect to sliding conditions. Cannot separate, cannot slide, like that they will give accordingly. Friction in the sense there will be some friction with respect to the target as well as the contact area, like that we will tell. Okay, then frictionless in the sense how it is acting, normal, tangential, rough, normal, tangential. In that way we will have the different contacts. So here once again we already discussed the nodes and things, separation things. So elements, you can able to see the contact. What is contact? In between two nodes, this joining is there, no? One node to other node, the joining point is called contact. Okay. So penetration occurs when contact compatibility is not enforced. Okay. Whenever we are not enforcing, you can able to see the contact in yellow color. The target is pressed, even though we are not penetrating the contact compatibly, it is not enforced. Okay, so that what the contact is trying to give in a detailed way. Pure penalty and augmented large contact formations. So just we are applying the formulas for the contact areas. Okay, these are all just formula things. Just I will skip this because I given for some other purpose for detailed things, since we are not in depth on this. We are moving to this. Okay, here this one point I want to tell. Contact with target. Actually, target you already know this. Yellow color is the target. I already shown. Yellow color is the target. And contact is the red color to between the nodes. So based on that, contact with target. Internally, the designation of the contact and target surface is very important. In simulation, under each contact region, the contact and target surfaces are shown. The normal of the contact surfaces are displayed in red, while those targets or surfaces in blue, as I told you already. Okay. In by default, ANSYS it will create the contact and the target automatically whenever we are applying the loads and forces. Okay. So based on that, target surface, contact surface, once again here showing it is a symmetric, asymmetric behavior. It is not a symmetric, it is asymmetric behavior. It is showing here. So comparisons for the formulations, just for understanding, we are including all the things in a single things like pure parallelity, augmented line, and normal line, MPC, beam. So each and every category we are explaining here with respect to the contact formulations. Okay. The next one is mesh. Mesh is very important thing. Earlier we saw that elements, how to create a elements, how to create a nodes, and what is the contact, what is the target, everything we saw that. Here, this is called mesh. Mesh is one of the most important step in performing accurate simulation using FEA. A mesh is made up of elements which contain nodes. Okay, mesh means it will contain nodes and represent the same of shape of geometry. Okay, here we are having a different types of meshings are there: tetrahedral, hexahedral, this kind of meshing types are there. Just I will show you in the picture itself. Here you can able to see. So how they are checking the mesh quality in finite element analysis. This is actually old methodology. Right now the software is very much advanced, so we can able to apply the mesh quality itself. It will automatically it will apply the recent mesh quality and it will generate the result. There is no need to investigate this what is the quality of this mesh and all. It is not required. Just for knowledge purpose only I have shared this. In order to achieve results with good reliability, the global model measures must meet minimum element quality above 0.15 inches. That is our one of the customer Vestas guidelines. Okay. Checking results. Whenever the checking results convergence and singularities, we have to see what are stress singularity. Stress singularity are artificial stresses computed between because of the simplification of FEA model. Okay, we are however we are doing the simplifications on the by dividing the component into elements, the analysis will get simplified. Okay, this is one of the thing. So then finally we are checking the results and we are getting the results done. Information available from various types of FEM analysis: static analysis, heat transfer analysis, dynamic analysis, fluid analysis. Static in the sense we can able to do analysis on deflection, stress, strain, forces, energies, etc. Heat transfer in the sense temperature, heat fluxes, thermal guidelines, heat flow from convection phases, etc. Dynamic analysis in the sense frequencies, deflections, stress, strain forces, energies. Then fluid analysis, pressure, gas temperatures, convection coefficients, velocities, etc. In automotive industry, where are the applications? Now, before that, we are seeing about various types of FEM analysis. Now, we are going to discuss about example on FEM application areas. Automotive industry, aerospace industries, architectural industries, and not only that, even in right now I'm working in wind turbine industry. So here and all, analyzing is a very much important point where everyone is doing very much concentrating on the analysis part, because right now the challenging softwares are available in the market. Earlier we will know only about ANSYS. ANSYS is the main key FEA tool we are using, and it is giving a good accurate result. Now also the same only ANSYS, it is giving a very good accurate results, but in market we are getting some other softwares also, because in ANSYS and all, by considering time, it is taking more time for analyzing the components. But comparatively, 2 years back, Altair is one of the company. They introduced SimSolid. It is one of the analysis tool where we can able to get the result within a minute. In that way, we can able to get the results. All the forces applied, meshing, everything, it is done by itself, and we are getting the results. I'm having some of the snapshots in upcoming slides where I will show that for your better understanding. In automotive industries, they are doing like static analysis, modal analysis, transient dynamics, heat transfer mechanisms, traction mechanics, metal forming, crash analysis. You can able to see this car and all crash analysis and all happening, right? So those kind of all analysis they will do, because safety is the main concern for all the peoples, like each individual, each departments, wherever we are going, human safety is the first highest priority thing. So for that purpose only this analysis and all there. Why we are doing this analysis? To safeguard ourselves, safeguard humans from unknown threats due to thermal power, or due to crash, or due to some other issues, external issues. So for that, in design, we are concentrating on analysis more. Initial stage and all, we are having a separate design team, separate analysis team in the industries will be there. Nowadays, as a concurrent engineering, all the departments are doing a cluster activity. For example, a person who is doing the design, he should do the analysis, then only he will come to know what is the issue in the design, where I can able to correct the design to get the right result in FEA analysis. Like that, we will compare the things and he will do. So nowadays, in most of the companies, they are practicing this way. Even in myself, I did the design. Asked my team to do the design, and by ask my team to do the analysis itself, I will review the analysis and I will close the thing. So like that, the practices we are providing in the industries for young engineers and all. So this is a very much important thing that everyone should know. Okay. And in aerospace industry, that is a little more complicated industry when we compare to roadside industries and like automotive or rail industries and all, roadway transport. But airway transport, we will give a specific accuracy, and specific things will be there, like more analysis we have to do, since we are using the vehicle for airways purpose. This much of accuracy in design itself, we will have the high standards. If we go through the standard for normal component standard, and if you are going for aerospace component standard, both there will be many difference will be there. It will be some more higher accuracy results they will be expecting. So in that way we want to do the analysis also. Okay. So now we will go to the case study. Role of simulation in design. So A Boeing 777 is the first jetliner to be 100% digitally designed using three-dimensional solid technology. This is the first flight they designed by using three-dimensional solid technology. Okay. Throughout the design process, the airplane was pre-assembled on the computer, eliminating the need of costly full-scale mock-up. First, they did the mock-up design, so everything is done pre-assembled in the computer itself to get the see the results. Okay, the like 2 lakh kg plane is in the biggest twin engine crane aircraft ever flight in the 375 passengers. Okay, so it is a very big flight. We are having this Boeing 777 flight is a very big flight. This is a twin engine aircraft. Okay, it can able to carry 375 passengers up to 7,400 kilometer, and from its first service flight in June 1995, and has been certified for extended range twin engine operations. Okay, Boeing invested more than 4 billion in CAD infrastructure for designing the Boeing 777 and repeated huge benefits from design automation. The more than 3 million parts were represented in the integrated database that allow designers to complete 3D virtual mock-up for the vehicle. Okay, so they are mostly concentrating on CAD infrastructure products. Okay, Boeing based its CAD system on CATIA. Actually, CATIA is the software they are using for a 3D thing. And Elfini, this is called finite element analysis tool they are using by the Dassault system. Okay, Dassault is a software system. They are providing these two softwares. Okay, to design the 777, Boeing organized its worker through 38 cross-functional design building teams responsible for the specific product. For the particular product, around 238 CFT members they are working for the outcome of this product. The team used 2,200 terminals and a computer-aided 3D dimensional interactive applications. Okay, for this assembly, the system worked so well that only a nose mock-up was built before assembly. The first flight vehicle was only 0.303 mm out of alignment when the port wing was attached. Okay. Boeing also included customer operators downline to the mechanic to help tell them how to design the plane. Okay. Once everything is done, this is a this is the success story for Boeing. Okay, so everything is fine and it got a very good result and there is no issues, so they are repeatedly doing this flight for the customer benefits. Okay, the next one is Airbus. They got some failures. They faced some failures in the design. Okay, Airbus A380 will be a truly castles with a model of seating triple five people. It is also a very big flight where 500 people can able to travel. Okay, in that they are facing some spacious issues. Like it is actually a very good cargo flight where they can able to get all the stairs. Everything is fine. And they are giving the very good classes also, economic classes, business class, first class, everything is done. But still, they are facing some failure in the things. So you can able to see here on Tuesday, February 14, a resounding crack echoed through the Airbus static test facility in Toulouse, France. Okay, the wing of Airbus had snapped between inboard and onboard engines and applied pressures approximately 1.4 times the load limit. Actually, they are having some load limit. Up to that load limit, it is acceptable range. But within the more than 1.4 times of the load, limited load, we are having a unpredicted load is happened, which makes failure on the flight. Okay, so whenever the load test they did, they are not faced this kind of extreme load condition failures. In that case, once again they started to investigate the issue and they are providing the solution why it is happened and what is the safety factor we are having. Any that time actually the passengers were available in the third class, they are not having any issues, but still they faced this issue. Hence they are addressing the issue by did the root cause analysis. What is the issue happened, when it is happened, and why it is happened, like 5-way analysis and all they have taken place. And finally they did a analysis on the particular case and they have rectified the issue, but still the failure occurred. That's the reason they are doing this root cause analysis to fix the issue. Okay, non-linear analysis and all they will do, and finally the problem was fixed, and A380 received certification from EASA and FAA. This is two things are standards that for safety and high safety purposes they are having this standard. So after the approval only, once again the flight is getting started to uh, use for customers. Okay. The next one is finite element model to analyze the Bay Bridge. Actually, the bridge and all they are making, right. So bridge, usually the bridge and all they will do for by simply supported beam calculations. They will start to investigating in the design areas. Okay. In response to the extensive damage caused in 1989 Loma Pritica earthquake, one earthquake happened in California. Okay. So that time what happened? The bridge got collapsed. Okay, the bridge got collapsed due to that earthquake. Okay, so in that case they took all the earlier analysis report and how it is reacting and what is the load is applied. So everything they start investigating. So here you can able to see this is one of the software analysis software they are doing for linear analysis. Okay, including large displacement, plasticity, and contact. There are six major toll bridges in California. After that earthquake, it got damaged. So one of the model here they are shown. Okay. Subsequently to the analysis, Adina was the software used in the California Department in the Transportation to contractors to design a brand new design section spanning from Oakland to Treasure Land. Actually, due to earthquake, this got damaged, but still better design they have introduced. And once again by using Adina software, uh, they compare the earthquake range and what is the load it is acted on the bridge. So everything they have compared and they have designed the component based on that. So these are the two things they did, and they successfully overcome the failure. Okay, this is one of the case study. Okay, this is one of the thing crash analysis for Ford. Okay, crash analysis it is. Okay, what is the load deformation here? Actually, the crash analysis in automobile and all. Usually nowadays the videos are available in the YouTube. You can able to see what is how the crash analysis is do. Based on the crash analysis only, we will give the star rating to the each product manufacturers. For example, Toyota, Hyundai, they are having a 5 star, 4 star, this kind of safety concern stars. No, these are stars and all uh, given by based on this crash analysis only. Okay, here one of the example crash analysis of automobiles is the simulation of a show dynamic process. In general, only codes basing on the expecting dynamic analysis procedures have been employed to the analyze to the crash response. Okay, simply whatever I said, right? The same thing. Adina is the software they are using for the crash analysis. So based on the crash analysis, uh, they are seeing the result and they are improving the improvising the design accordingly. Okay, here you can able to see this is how the animation we are showing here is placed, and the result you can able to see like this. So what is the displacement happened and based on the total number of load how much it is acting. So what is the data it is having, what is the maximum limit it is touching. So when it is getting crushing, so up to which limit it is acceptable range. So everything, every data it is stored in the software, and we can able to predict the result based on the software output. So like this we are having various FEM solutions. which is a wide ranger and growing wider. Like you can able to see these are the different kind of FEM applications we are doing in the analyzing the problems. So this is one of the cantilever beam with uniform load, and how the result it is coming. So this is the thing, and the results how it is showing. This is ANSYS toolbar. This is old version. In latest version, it will go give more accurate results. This is the car tire analysis report. So how the car tire is manufacturing, and what is the maximum pressure it is handling, and what is the temperature, thermal analysis, everything. Because there will be a friction between road and the tire, so automatically friction will be there. So based on the friction, there will be a temperature will be rise, and what is the maximum temperature, and what is the wear and tear. So everything, every details we can able to check by using the analysis software. Here also we can able to show this is a cross section view of this tire, where we can able to see the elements. Here also we are providing the elements. You can able to see elements one by two. Like these are the elements nodes, each and every elements with respect to the nodes we are creating, and it is called meshing. All overall it is called meshing, and based on that we are getting the result, how whether it is suitable to manufacturing the things or not. Everything we will get the result before starting the manufacturing. So this is one of the guitar. Guitar is one of the example where guitar usually we are having the strings, right? There will be a string. So each and every string we will have some we will apply some force to get the noise. Okay, get the noise or music, whatever it is. So there will be some force we will apply through our hand. Okay, so how much force we can able to maximum apply, and what is the maximum vibration it is occurring into the string. So each and every calculations it will apply, and it will get into the things. Okay. So this is the I told no vibrations. So this is another thing, tuning fork. Okay, dynamic analysis of tuning fork. Just from the original position, if you are doing the analysis in the sense from 1 to 8, you can able to see how the deformation is happening, how the vibration is happening, and how the deformation is happening, and it will come to the original position once everything is doing. These vibrations and all, it will act into a fraction of seconds. Within a fraction of seconds this will happen, but in analysis we can able to see one by one how it is applying, how it is doing all the things we can able to see. Okay. The next one is case study using sim solid analysis. So here this is actually a tower. You can we can tell like wind turbine. You all know about wind turbine, right? Wind turbine we are having the tower, tower 1, 2, 3. These are the three sections we are having the tower. Actually it is a normally it is a land. There are two types of towers are there. One is offshore wind turbine, another one is onshore wind turbine. This is actually a offshore wind turbine which is available in the seashore. Okay, so in the seashore, this tower we are having some issues, like the cable. I can the second picture you can able to see the cable, right? A red color cable. This is actually high voltage cable. Okay, this high voltage cable. Whenever the person is climbing the ladder, this cable it is disturbing him when he is traveling to this ladder from one section to another section. So what we did is we redesigned this. We redesigned this, and we just moved this cable away from the ladder. Okay, away from the ladder as well as these clamps. Okay, so just we are ensuring that our design is okay or not. Okay, because just we are moving the original design to redesigning the things, but when redesigning is done we want to verify whether our redesigning is right or wrong. So for verification purpose we did a FEA analysis. Okay, as I told you already, here we are using SimSolid. SimSolid is one of the uh, very latest analyzing tool, which is launched 2 years back by Altair, 2 years or 3 years, I think. Altair. Here you can able to see the result. Like before I started analyzing this particular area because a whole uh, ladder itself, if I start doing analyzing, means it is a waste of time. Only the particular area where I touched the cable, that area alone I'm going to do the analysis. Okay. So for that, these are the conditions. Like in the software itself, we will have some connections conditions. This is one of the wind turbine case study where we will do the some fastener connections and regular connections by doing the calculation. As I told you, we want to analyze the FEA means first of all we want to understand the material of the component is very important. So what is the material and what is the yield strength? Based on the yield strength, what is the maximum stress it can able to withstand? Okay, so like that we want to do. For example, for this material, particular material, 204 MPa is the 204 MPa is the stress limit. But whatever in the software we observed only 162. So it is safer. Okay, that what we are understanding from manual thing with respect to the available stresses which is from the software. Once everything is done, like this we are doing the analysis. Okay, so based on the load we are applying the load to the component. You can able to see here with respect to that in the clamp, this is the clamp, where this is the clamp, we are applying the load here into the clamp where the cable is passing through. Here the cable is passing, right? The cable is passing through this clamp only. You can able to see this circle. Within this clamp only it is going. So the load is acting in the inside of the clamp area. So in the clamp area, if the load is passing, so what is the maximum load? 672 Newton. It is the maximum load we are applying, and we are testing the displacement. First of all, we are displacing, checking the displacement. You can able to see here maximum displacement is 1.62 plus e power plus 2. That is called 162 MPa. Okay, this is the maximum stress and this is the maximum displacement we are getting into the thing, which is result in the with respect to yield strength. This is the OK design where we can able to uh, do the right analysis. Okay. Next one is advantages of FEA. Here you can able to see the advantages: can readily handle very complex geometry, can handle a wide variety of engineering problems, can handle complex restraints, can handle complex loading. Okay, a general closed form solution. Disadvantages in the sense it is a closed form solution. We cannot predict the things what it is going to happen, whether it is positive or negative. We don't know. Okay, so that is one of the disadvantage. But it is not. I will not tell this as a disadvantage because everything we cannot do a manual calculation, and we want to ensure the design. We can cross verify, but still the software is required to save the time because nowadays the competition is very high. So in that case, we want to be more conscious on the results which is giving within the time whatever the customer is providing for the solutions. Okay, the FEM has inherent errors, mistakes by users. User mistakes, it will happen not only in FEA, in everywhere. Input is wrong means output will be wrong. That what the main intentions. So applications, other applications of FEM, we can go for civil engineering structures where static analysis of trusses, flood plates, shells, roofs, shear walls, bridges, and precious concrete structures, etc. Aircraft structures, structural analysis of aircraft wings, all kind of aircraft things it is required. Heat conduction, geomechanics, hydraulic and water resource engineering, nuclear engineering, biomedical, mechanical design, electrical machines, and electromagnetics. Wherever we are going with a product, FEA is playing a vital role in all applications, which is very important. These are some examples: crash analysis, modeling of a gear coupling, can drop test. Even for a Pepsi or Coke can, what is the crush when we are making a force to crush the bottle? So what is the load is acting on the bottle and how much it is withstanding? If it is putting down in the sense, what is the contact point? First contact point that is getting touching with the floor. So each and everything is analyzing things only. Each and everything we want to think in that way. Okay. So crack growth analysis. So for example, this kind of things in a pressurized pressure tank, you can able to find a small crack. That crack, how it is occurring, and in case if crack is there, means what is the pressure loss it is happening, how we are going to check the things. So each and everything we want to do as per the things. Okay. Future trends in FEM and simulation. The FEM in particular and simulation in general are becoming integrating with the entire product development process. That is, FEM cannot become bottleneck. Yeah, broader range of people are using FEM nowadays. Everyone is doing FEM. If for a simple component also they are doing FEM. If they are not having any software or license, in the sense they are contacting the external agencies to get their product to analyze and get the results whether our design is right or wrong. All peoples are nowadays they are doing. FEM software is becoming easier to use. For example, as I shown you the SimSolid, right? The SimSolid tool is very much easier, but we cannot expect very accurate result. But we can able to see the overall result. The concept design is okay. For example, when I designed this, I shown that example for SimSolid. I decided that okay, this component is safe. Only that reason is required for the result is required for that test. Instead of going for answers, doing all the analysis, getting the result, finally, okay, this design is safe. Instead of that, by using this SimSolid, I am simplifying the analysis. So that is called GUI is speaking. Improved GUI means global user interface. That is very much easier to understandable for the peoples who are working in analysis. Okay. Then future trends again continuing. Enhanced multiphysics capabilities are coming. Improved life predictors, improved service estimations, increasing a non-deterministic analysis, faster and more powerful computer hardware, decreasing reliance on testing, FEM and simulation software available via internet subscription. Any questions?
Dear
Dear
participants, any
participants,
questions
any
from your end?
questions from your end?
I'm audible, sir.
Yeah.
Sir, I'm having small
Yeah.
doubt. What are
Yes.
the current gaps in industrial FEA workflows where academic research can contribute significantly?
You can go with like nowadays FPA is very vitally played in the industrial areas. Even as I said, even for a small industries, they are approaching analysis things. Gap in the sense right now they are filling the gap. But in meshing area, right? I told you that node meshing area. Usually, whenever the big softwares, big structural components, assembly components, and all, for creating the elements, meshing, it is taking more time. And analysis, one of the drawback is it is taking more time. Just we want to reduce the time where I can able to find a gap in that, because as I said, SimSolid tool, it won't take much time, but I am not getting very accurate result. For that purpose of application, that result is fine. But for major industries like aircraft and all, if you are going means,
Message getting
SimSolid
accepted.
software is not suitable. In that way, ANSYS we want to implement or any other tool we want to implement where the time is taking more. We want to reduce the time. For that, any research analysis if you are doing means it will be good to do the meshing things, reducing the time in that area, or else related to that. If you are for reducing the analysis time, if you are putting some efforts in analyzing area means, then it is fine in research papers. Hope
Okay,
I'm
thank
answered your
you.
question, right?
Sir, I'm having another question.
Yeah.
Are industries using digital twins based on FEA?
What come again?
Are industries using digital twins based on FEA?
Digital pins means
Digital twins.
uh, no idea. Digital twins, new word. I not heard about that.
Ah,
Maybe some
okay.
other term I may use, I think.
It's a replica of a physical system, sir, which digital
Okay.
twins means. Hmm.
Okay. And like it is a common thing. Like a product is there in the sense we are applying the product into FE analysis. There is no need for like your product. If it is okay or not, either okay or not. If you want to identify in the sense, just we can take a small element and we can do the analysis instead of doing a complete prototype model. We can do a small area and we can able to get the result if by applying the material. That what the thing instead of doing all the whole things.
Sir, one more question, sir.
Yeah.
How can FEA be integrated with machine learning for defect prediction or optimization?
Predicting it is a like machine learning. FEA will not helpful like FEA is a tool where we are going to analyze and we are going to get the result whether everything is fine. We can incorporate that like whenever we are doing the machine design or something in the sense by concentrating on the material and a load, we can able to predict the application where the application is used. Based on that we want to get it is not directly related anything with machine learning and FEA. Once everything is done, FEA will come inside. Yeah. Any other questions?
Sir,
Yeah.
what about that boundary conditions and its implication in FEA model, sir? Because most of the things we gone wrong with the boundary conditions, we are unable to apply the exact boundary conditions on the particular component. So
Okay.
normally in industries, what are the common techniques you use to match the similar boundary conditions on the FEA model?
That would is like whatever the boundary conditions, we will split up into the elements. Each area, for example, a square block. If I am taking a square block in the sense, directly I will not put the analysis square block. I will not put the analysis. I will do a element analysis. Each and every element with respect to the nodes, I will split up the things and I will start investigating the analysis. Sir. So each and every element in the sense, the system automatically the software it will itself. It will decide what is the my boundary condition and how I'm going to give the result. Like that it will predicted in those things. For example, in college we will learn all the things one by one, but in industry it is totally different. Just we are applying the things to get the results. That's all. If any results is abnormal, then we will start investigating why it is abnormal. What is the material? What is the density? This kind of in-depth analysis. After that, we will do based on the results. Hope it's fine, sir.
Yes, sir. Any few more questions from the participants? Sunil Dagubati, do you have any questions? Okay. Anyhow, thank you, sir. Thank you, Rajesh, sir. This was really a wonderful session, and the participants are also expressed
Your
their
voice is not audible.
hello.
Hello. Yeah, now it is fine.
Thank you, Rajesh, sir. And the participants are expressed. It was a very nice presentation, and thank you very much for it.
Yeah, thank you, sir. Thank you.
Thank you. My dear participants, with this, today's sessions are closed, and tomorrow we will meet by 6 p.m. sharp. And I will share the feedback link shortly for the session 2. Thank you very much, and have a great night. Thank you.
Yeah, thank you. Thank you all.